Hi, today I'm going to discuss complex number calculations in Microsoft Excel. Complex number calculations is very important in electrical engineering. We use it to represent different electrical variables such as impedances, voltage, current, and power. In today's topic, I'm going to show you how to use it in equivalent impedance calculations. Let's first review some basic knowledge about impedance. In this slide, we can see the impedance triangle represented by the resistance R, the reactance X, and the impedance Z. We can write it in rectangular form R plus JX or in polar form Z angle theta. To convert rectangular to polar form, so Z is equal to the square root of the sum of the squares of R and X, while the angle theta is equal to the arctangent of the ratio X over R. While converting polar to rectangular form, R is equal to Z times cosine theta, while X is equal to Z times sine theta. Now, how do we solve equivalent impedances such as series impedances or parallel impedances? So I'm going to show you an example. We have series impedances here, Z1 in series with Z2 in series Z3. To compute for the total impedance ZT, we have Z1 plus Z2 plus Z3. ZT is equal to R1 plus JX1 plus R2 plus JX2 plus R3 plus JX3. Then we have RT is equal to R1 plus R2 plus R3. And XT is equal to J X1 plus X2 plus X3. To calculate the parallel impedances, so in this example, we have Z1 in parallel with Z2 in parallel with Z3. So the reciprocal of the total impedance is the sum of the reciprocal of all the impedances, Z1 plus Z2 plus Z3. So we have 1 over ZT is equal to 1 over Z1 plus 1 over Z2 plus 1 over Z3. So in the next following slides, we will show you in how do we do this in Excel. In here, we have sample complex number calculation of series impedances in Excel. So we have Z1 in series with Z2 and in series with Z3. To compute for the total impedance ZT, we have ZT is equal to Z1 plus Z2 plus Z3. We then write Z1, Z2, and Z3. So in Microsoft Excel, we must write the complex number in the form 2 plus 3i. So notice that instead of 2 plus J3, we write 2 plus 3i. Then for the Z2, we have 4 plus 4i. For Z3, we have 4 plus 6i. To compute for the total impedance ZT, we have IM sum, which is the formula for the sum of the complex numbers, and then we highlight Z1, Z2, and Z3. So then we compute for the ZT. Other way around, we type IM sum, and then we highlight all the complex numbers here. So that's the total impedance of the series circuit. Next, we do the complex number calculation of parallel impedances in Excel. So we have Z1 in parallel with Z2 and in parallel with Z3. So to compute for the total impedance ZT, so 1 over ZT is equal to 1 over Z1 plus 1 over Z2 plus 1 over Z3. Then we list all the impedance. Z1 is equal to 2 plus 3i. Then C2 is equal to 4 plus 4i. J3 is equal to 4 plus 6i. And then we convert these impedances into their reciprocals, 1 over z, by using the formula for division of complex number, which is IMD over 1 over the complex number 2 plus 3i. Then we just copy this formula for the next remaining J2 and J3. Then for the total impedance, the reciprocal of the total impedance, so we just sum up the reciprocal of all the impedances. IM sum of these impedance, reciprocal of impedances. Zt is equal to the reciprocal of 1 over Zt. So IMD over 1 over this number. So we have the total impedances of the parallel circuit. Next, I am going to show you some Excel functions that we can use in complex calculation in Excel. So first, we are going to use the complex L, X, and Y, which converts the real and imaginary number into a complex number form, in the form x plus yi or x plus yj. So here is a formula that will yield the result. So we have an example. So we type in complex of 4 and 5. That will yield 4 plus 5i. So another way is we type the real and the imaginary number separately, 4 and 5. And then we type in complex of the real number 4 and 5. That will yield the same result, 4 plus 5i. The next function is IMReal, which returns the real coefficient of a complex number in the form x plus yi. So we just type here IMReal of the complex number 4 plus 5i, then it will yield 4. Next is the imaginary number, which will yield the imaginary number of the complex number. So in this case we have 5. Next is the IM absolute, so which yields the absolute value or the modulus of a complex number. Okay. Next is the IM argument, which returns the theta of the complex number in radians. So IM argument of the complex number. So this is in radian. So if we want this in degrees, we can type IM argument of the complex number times the conversion 180 degrees divided by pi radian. For the next functions, okay, we have the sum of all of the complex numbers, which returns the sum of 2 or more complex numbers. So IM sum of these complex number. So we can type IM sum, then open parentheses 1 plus 1i, comma 2 plus 4i, close parenthesis. Another way is we type in the two complex numbers, so 1 plus 1i, then 2 plus 4i, then we just type im sum, open parenthesis, say 1, then say 2. Close parenthesis. Okay, which yields the same result. Next is the difference of two complex numbers using the function im sub. Okay, so for this example, we have 4 plus 5i and then minus 2 plus 2i. Im sub, so 4 plus 5i minus 2 plus 3i, we have 2 plus 2i. Next, we have im product of 1 plus 2i, 1 plus 3i, so im product, so this returns the product of two or more complex numbers. Im product, then we choose h7 and 1 plus 3i, which yields negative 5 plus 5i. Next is the quotient of two complex numbers. We use the function imdiv. So imdiv, we have 1 plus 2i and 1 plus 3i. So we have imdiv of 1 plus 2i over 1 plus 3i. Okay. Next is the im conjugate, which return the conjugate of a complex number. So we can type in, here is 4 plus 5i. Taking the conjugate of this complex number, we will have im conjugate of the complex number 4 plus 5i equals 4 minus 5i. That is all, everybody. Thank you very much for watching my video. I hope you like it. If you like it, please subscribe and click the bell button to get updates on my new uploaded videos.